Assalamualaikum. Today, me and my team are going to present about digital identity management. So, what are all of this about? So, you can see here that we are going to talk a lot about self-sovereign identity and zero knowledge proofs and about centralized and decentralized database and we also go into real cases of Malaysia's under 16 social media ban. How do we confirm ourselves to them that we are above 16 but without giving our ICs or passports? Because it contains a lot of information other than our birth date, right? So how do we give the information to them? So we'll delve into that. We'll also look at things like, how can people buy alcohol if they are above 21 but they don't want to show their ID. We will also go into the tamper-proof security using RSA 2048 PID keys. It also has a algorithm of SHA-256. So we'll go into SSI, ZKP, and we'll tell why blockchain is so important in today's time. Before moving on to the blockchain, I just want to show you what has we been using for the past 50 years or so using our old technology. We have one centralized database, right? So don't you think it's a very high value target if once it's leaked, everything is leaked. So the whole company needs to shut down. And these things happen if hackers get their hand on even a single password. They can break a lot of things. But what if we do blockchain? In that case, even if hackers try to manipulate a variable inside the blockchain, it will only be for that blockchain only. The rest of the database is still okay. And how do we make sure that it's not just us that has the data, but also the users? We are also dependent on the users. How do we make them? We'll go into the blockchain. The very basics of decentralized identity (DID) is the issuer, the holder, and also the verifier. So who's the issuer? The one who holds everything about our ID, which is the government. So who is the holder? We are the holder. We have the private key and the verifier. So the verifier is the platform that is requesting our information. I've actually created a website on simulating the blockchain. It's not 100% perfect, but it tries its best to show what blockchain looks like, how a database does not hold all the information. Even the users hold some of the information. We'll go into the web practical proof. So this is the website that we want to show you on how blockchain works. So yeah, we have this decentralized identifier, the ID generation. What we have here is the target identity URI. You can just create anyone. I've created 5, but you can create more. So let's create one identity first. So let's say 1111. So under the name Aslam. So I will press generate, and then we get the signature, we get the private wallet key, and you can see here inside Oracle, this is actually like the SQL query that is executed. I just want to show you here. The only thing that is stored in Oracle is the DID URI and also the public key anchor. It does not store this. It doesn't store this. We have a private wallet key, only we have it, and the with the private wallet key we can create a signature, right? So we take that signature, we take that holder the ID target, and then we put the ID. So actually the website doesn't know our ID actually. So when we press the verify, it can verify with the ID. it shows that the original hash and the current ID payload hash is the same. What if I change the ID? See, now the security is blocked. But the thing is, my ID is not stored inside any databases. It has a lot of calculation going on behind with SHA-256 and the RSA 2048 with key pair for making this public and private wallet key. So basically, on how this thing is, it is on two part security. It's not a central database. It's not a centralized database. So even if I remove a letter and then put something else, even if I get the right ID, it's still wrong. If I put the correct signature again, then only it will give you the correct identity authenticated.
So basically there is three steps that we would like to highlight, and the first step is the cryptographic registration and ledger anchoring. So for the step 1, this is where the identity registration happens. As you can see on the left side, the issuer, or in this case is the university admin, enter two things: the DID pointer, which acts like a unique identity address, and the 4-digit student ID as the identity claim. And once it is submitted, the system will perform what we call the key pair generation, shown here as the split. It generates two keys from one process. The public keys is sent to the Oracle ledger on the server side, where it gets permanently anchored there. But the private key, this goes into what we call the client side vault, and it will stay there only. It will never be transmitted to the server at any time or at any point. It will stay at the client side only. This is highlighted here at the bottom because it is the core of SSI principle. There is no third party, or not even the university, can access or revoke the private key itself. The holder or the owner owns it completely, and this is what makes it self-sovereign. Okay, moving on to the second step, which is the decentralized verification via the Oracle. So for the second step, it is a verification site. Like, imagine a third party, and maybe an employer, they want to verify the identity of the student. They don't need to call or contact the university at all. They just need to use the verifier portal. So what they need to do is they need to enter three things: the DID, the cryptographic signature, which was generated previously on the step 1, and lastly the 4-digit student ID. After they enter these three things, the system then goes to the Oracle schema and resolves the public key that was anchored earlier. It uses that public key to check whether the signature is valid. As you can see on the right part, the result come back as match, and the access was granted. And the important point here, as shown in the bottom, is that the original issuer is entirely bypassed. The verifier never needed to contact the university at all. That is where the trust is established purely through cryptographic proof on the ledger itself. Okay, for the third step, or the last step, which is the detecting tamper attacks or error through the SHA-256 hashing. It is where we will detect any kind of error, whether it is human error or a deliberate tamper attack. So for the first scenario, we can look at the scenario A here. Here, someone's entered a wrong student ID. Instead of 6767, he or she entered 6768. So it is wrong. The system will immediately return rejected because it is an invalid key, along with a completely different SHA-256 hash. So even a human can do a mistake here, and it will caught immediately. On the right scenario, which is the scenario B, it is programmatic attack. This simulates an automated attempt to forge the credential. The system inject a 999 as the student ID, and the result is tampered, again with a different hash entirely. The takeaway here we highlighted at the bottom is that even altering a single digit fundamentally changed the cryptographic hash. So credential reuse, forgery, or any form of manipulation, the system detects it immediately. This is the power of SHA-256. combined with blockchain anchored identity.
So this is a real pilot by Civic and Budweiser. A user ID is pre-verified and issued as a signed credential in their Civic digital wallet. And we can see the QR code here. When the one appear, the vending machine shows a QR code, an automated proof request asking proof the holder of this wallet is over 21. And the phone doesn't send any personal data. It generates a zero-knowledge proof, just true or false. The machine checks that proof against the blockchain ledger, and if valid, the beer drops, and if not, it locks down. So the law gets enforced, but personal data is never exposed. So what is exactly a zero-knowledge proof? Simple example. Alice say, I'm over 18, and Bob say, prove it. Instead of handing over her physical ID, Alice sends back a cryptographic response generated from her valid credential, and Pop system just checks it and returns accept or reject. And we can see the filtration diagram here. That's exactly what happens. Sensitive data like birth date, name, address gets blocked by this cryptographic wall, and all that comes out is one verified answer, is 21 and confirm. That gives us three key things. First, ultimate data privacy, since your raw data is never exposed. Second, a binary true or false answer instead of a full ID. And third, a tamper-proof verification, because it's checked against the blockchain. If your data doesn't meet the requirement, the math simply won't work out. This is the engine behind the privacy part of decentralized identity.
Next, I will talk about My Digital ID. My Digital ID is an application that is made by the government that serves as a digital identity system. It does not replace the usual MyCard that every Malaysian has. However, it serves as an identity and a verifying system for Malaysian users to verify themselves in other digital apps. For example, social media apps will use the My Digital ID as an electronic Know Your Customer, or also known as EKYC, to verify the user's age to make sure they are above the age of 16. The application works alongside national blockchains like Ztrix to make sure that users can secure their verification of age or identity without leaking their information to other foreign companies. Now we will go in depth in the Malaysia's under 16 mandate. Recently, the Malaysian government has issued a mandate that bans teenagers under the age of 16 to access social media applications. This means that those social media applications need to verify their users to make sure that they are over the age of 16. However, the traditional online verification system is not ideal since it forces the users to give their personal information and identity to those foreign companies. So the Malaysian government has another alternative for using a decentralized system that is using blockchain technology. As I mentioned before, the national application that is My Digital ID works alongside Ztrix, which is the national blockchain company, to store the citizens' data securely and to make sure that there is no tampering. Because of this, the National My Digital ID application can be used as an electronic Know Your Customer or EKYC for social media to use to verify their users' age without knowing other um, personal information. So this will not allow the social media applications to gather the user's data without consent. So here is the registration for the My Digital ID application. So first, the application can be downloaded on the smartphone by the Play Store or the Apple Store. So to register for the application, you will need to enter your email address for the one-time password or the OTP, and then you will have to enter your details such as full name and MyCat number. Then you will have to verify yourself using eKYC. So you will have to capture the photo of your physical my card, and then you will have to scan your face uh, using a live facial scan to make sure that your identity is verified, um, that matches with the my card. You can also go to a physical kiosk as an alternative if you cannot register online in your for on your own. So they will help you to register your My Digital ID application. So once you've registered the My Digital ID, you are able to use it as a verification for other applications without you sending your additional data to them. So only the required data for you to verify yourself on in other applications is required.
Okay, moving on to the next slide, we are evaluating the core trait of this system, security versus scalability. Let's start with the benefits. This approach gives us robust tamper-proof security through cryptographic hashing because the data isn't held in one place. We completely eliminate centralized honeypot, risks that are prime target for attackers. Additionally, it allows us to automate legal compliance without exposing sensitive personally identifiable information or PRL. However, the security features introduce massive hurdles. The primary issue is scalability and latency. Achieving a consensus on a zero-knowledge proof, which is ZKP, network demands immense computer power to the point where users have faced wait times of up to 20 minutes just to verify a transaction. Finally, there is a major infrastructure independency. The success of this paradigm relies entirely on the widespread public adoption of base layer identity systems such as MyDigital ID. In short, while the cryptographic security is exceptional, the computational overhead and reliance on external infrastructure currently present significant bottlenecks. Turning to the next slide, we see 5 key trends driving the future of digital autonomy. The first one, Universal Self-Sovereign Identity, which is shortened to SSI. From this perspective, users will manage their entire digital presence through a single secure wallet. The second one is decentralized social media. Blockchain architecture will ensure privacy by default and prevent corporate data hoarding. Third, national blockchain integration. State verified credential like My Digital ID will link with blockchain networks for seamless legal compliance. The fourth one is optimizing scalability. We are overcoming latency hurdles to make real-time cryptographic proofs instant and practical for daily use. Finally, binary proof standardization. System will rely on simple true-false verification like confirming someone is over 16 without ever exposing the underlying sensitive data. In a sense, these 5 steps fundamentally restore user sovereignty and move us toward a privacy-first digital ecosystem.
Okay, so yeah, that's basically all the things covered for this decentralized identity for digital identity management. What have we learned throughout all these things? So we have learned about decentralized self-sovereignty, the SSI. You know how the confirmation requires both the user and also the platform to verify whether the information is correct or not. By using ZKP and Know Your Customer, it uses privacy preserving verification where it verifies, but also at the same time it protects our privacy. And we have a lot of we have gone into the future autonomies and their challenges. So there's a lot of things that can be improved with this blockchain technology. Maybe in the future we may even um, take away all of the centralized database and uh, change everything with blockchain. So these are the references. If you want to check more, it's on the document that we have sent. That is all of our presentation. Thank you, Doctor, for watching.